How are folks doing? Cool.
Well,
So I think this is the last theme to get up and going. No, one more. Beatles still have, yeah. And we've been doing these kind of Q&As before to get launched so that folks can be able to ask questions and also to kind of point you to resources and things like that. So I will we can do a quick, it's always fun to see who's in this. So if folks want to give a quick round of kind of introductions, very brief. I'm interested in kind of your name and kind of your affiliation, and then whether you're part of a joint team here, and a little bit briefly about kind of your approach to the challenge, so we have an idea about kind of where folks are. So I'll go ahead and get started. I'm Quinn Thomas, faculty at Virginia Tech, and am the PI of the Research Coordination Network within Ecological Forecasting Initiative. And the principal task that it's focused on right now is the NEON Ecological Forecasting Challenge. And so been involved in the design of the rules and the CI and getting all the teams organized. So I'm really excited to see everybody here, and this is awesome. You're also coming in at a good time because we've had a lot of opportunities to refine the different tools that I'll show you that's available for you to work with. The teams that started in February, or the themes that started in February, really had to be the guinea pigs. So cool. I'll see. Jody, do you want to go?
Yes, when I can find the unmute button. So I'm Jody Peters. I'm based at the University of Notre Dame, and I'm the program manager for EFI. So I help coordinate what's happening with the RCN and the forecasting challenges, and then broader EFI efforts as well. And so a lot of times when you get emails from the Eco Forecast Gmail, that's coming from me. And if you have any questions, please feel free to reach out. I put in the chat, and I'll do it again in case there's people that joined after I put my notes in the chat, but I'm taking notes for the call, and we're recording the call, so anyone that couldn't make the call, will make these resources available to them as well. And then I will popcorn it over to Mike.
Hi, I'm Mike Dietz from the Department of Earth and Environment at Boston University. I am EFI's chair and kind of one of the folks instrumental in the original founding of EFI as an organization. I am not probably the least aquatic person on this call, but mostly here just to provide general information. Yeah, I'll pass over on my screen. Paul, you're next to me, so I'll go to you.
Great, thanks, Mike, and hi, everybody. I'm Paul Hansen from the University of Wisconsin. I am an aquatic ecosystems modeler, and I volunteered to organize the Beyond the Water group. And our approach generally has been a call for participation, and then we all looked at each other going, how do we do this? And fortunately, Jake's part of our group, so he's provided mentoring, but it's been truly a team effort. Everyone has stepped up, and we're all learning simultaneously, myself included. So it's been great. Do you want me to pass it on to the next person, or okay?
Paul, it already sounds like the Research Coordination Network is achieving one of its objectives. If
excellent,
you went and thought about, you wanted to do it, and you realized that there was some learning and communication and coordination involved, because that's exactly what we want to do. So that's really great to hear.
Great. Thanks, Quinn. Mohammed, I'll pass it off to you.
Yeah, thanks. I'm Mohammed Shahani from Helmholtz Center for Environmental Research in Magdeburg, Germany. I'm a member of the task force of also Beyond the Water team, commanded by Paul. I do like modeling and seasonal forecast for living, and this was like a new time, temporal scale, totally new methods. It was like a mix of fun and frustration. I'm enjoying this. I think I'll pass it on to Kelly.
Hi, everyone. I'm Kelly Handula. I'm a postdoc with NEON and also part of the Beyond the Water team. I am also new to the forecasting world. My background's in aquatic biogeochemistry, but much more from the sort of empirical and analytical side of things. So I am also learning a lot. I will pass it off to Ryan.
Thanks, Kelly. Hey, everyone. My name is Ryan McClure. I'm a postdoc at Virginia Tech with Quinn Thomas and Caitlin Carey. And my emphasis and research and work has been working to develop some forecasts using a forecasting system developed by Quinn in some of the Neon Lake sites, and also had the pleasure to work a little bit with some folks on this call to help kind of coordinate and put this this challenge together. So it was a really exciting experience. And so I'm really happy to be here with everyone and get everyone's perspectives and questions. So with that, I'll go ahead and pass it over to Maria.
An important thing, Ryan mentioned, the fact that, that we've been working on forecasting neon lakes. And the really cool thing about a genuine forecasting challenge where you're forecasting data before it's been observed is that there's no inside track. There's not, you don't know the data. So we're all on the same kind of playing field in terms of because a lot of data science challenges, you withhold the data, but you already have it. And so the organizers can't participate. But in this case, the organizers can, because we don't know what the data looks like.
Yeah.
And so that's what's really together. That's what's really, yes. Neon won't look, but we're slowly working with Neon to get the data latency down, so that no one has that ability. Anyway, but that's what's really cool about genuinely predicting the future.
Okay, I am Maria, fourth year and hopefully last year PhD student based in Ireland in Love Field, doing a lot of work with Elvira, with planktonic communities, and as Kelly said, more like into the analytical and lab based skills. But I thought that this was a great opportunity to learn more about forecasting, and I know nothing but learning a lot with Paul team. I'm trying to help at some point. And yeah, really looking forward to know what you're doing, and yeah, just participate in a funny way, but also trying to learn a lot. And maybe Marcus?
Hello, everyone. I'm Marcus. I'm a second year PhD student at UC Berkeley in the Bediger group. And I'm leading, I think it's the Cal Water Bears team. And it's a pretty kind of eclectic group, but it's mainly undergrads. And I don't have any background in forecasting or aquatics, so it's kind of like the blind leading the blind. But it's been a great experience, and yeah, I've definitely been learning a lot. So with that, I'll pass it on.
Marcus, are you part of the class? Were you part of the class, or are? I don't forget.
Yes. Yeah. So yeah, Carl kind of he led a forecasting class, and it's just like
it's a seminar.
I mean, right? The only assignment was submit a forecast, so that's it.
That also relates to the students and early career folks on the call, that there is a student workshop that is in June. I think Jody, could you dump a link into there about it? That is an opportunity to learn more about the nuts and bolts of how to submit a forecast to the challenge, workflows, some things you probably haven't been kind of exposed to, some of which you have. And then if you have contributed to the challenge, or there's opportunities to give a flash talk about your work and about your team. So Marcus, you could give one of the 3-minute or 5-minute talks about the lessons that you learned from it, and it'd be an opportunity to kind of get to know other folks. And it's a really good group. And so I definitely encourage folks to look at that. It's free, pretty low time commitment, virtual. Awesome. So who are you popcorning to?
Yeah, sounds good. I'll try to make it. I'll pass it to Austin.
Hi, my name is Austin. I'm a master's student at the University of Wisconsin in Madison. This is kind of my first introduction to forecasting. I am just getting into lake modeling now, so I'm really excited. I'm very much learning a lot right now. It's kind of the stage where I'm at right now, but really excited to be here. I can pass it to Robert.
Thanks. Hi, my name is Robert. I'm a postdoc at the University of Wisconsin-Madison, mostly getting paid to do aquatic ecosystem modeling, but I'm also part of the Beyond the Water group, and I'm really excited to learn more about how to do a forecast or how to code the forecast yourself. Jake, you want to go next?
Sure. Yeah, I'm Jake Swart. I'm a data scientist at the U.S. Geological Survey. I'm based in South Bend, Indiana. I've been working with the Beyond the Water team, which has been really fun and exciting to see all the different ideas and teamwork get together. And then I've also been helping out with the EFI Aquatics team to initially set up the challenge. I'll pass it to Carolina.
Yes, can you hear me?
Yeah.
Thanks. So my name is Carolina. I'm a PhD candidate at the University of São Paulo, Brazil, and I work with ecological modeling, and I'm super excited to know more about forecasting, and it's a pleasure to be here. So thanks. I don't know if someone.
Sarah's the last remaining one since you joined. You don't know who everyone went through, so you're popcorning to Sarah.
Hi, I'm Sarah Burnett. I am a finishing PhD candidate at the University of Idaho. I work mostly in a reservoir system that deals with harmful algae blooms. So part of my interest is working and learning how to forecast those occurrences with some of the data that I have. Unfortunately, that's not necessarily in my dissertation, but it's something I'd like to work on. And I was also part of the group helping with the NEON aquatic forecasting planning too, along with Ryan and Jake.
Great. First of all, thanks everyone again for being here. It's an honor to have you folks here. I mean, this is really a function of the community, and what I'm most excited about is that we've spent a lot of time talking about forecasting, and now we have a focal point. And it's just great that everyone is using this exactly what we're excited about you using it for, which is to learn more, grow the community, and I don't know, discover the predictability of aquatic ecosystems. So the challenge, this is the first year of the challenge. So number one is it's important that you know that it's beta round, meaning that we're working out kinks, and you are as much of part of the design and implementation as you are a contributor, meaning that if something isn't clear to you, let us know. If something doesn't work for you, let us know. If you have ideas on how you want it to look next year, let us know. And we're going to be promoting the joining of the design teams, and so in the fall, and the initial design teams had a lot of boot up work, and I imagine the second round will be a little bit more refinement. But if you can think about other things you would like to forecast, different lakes, different variables, different time horizons, as you're doing this, think about what interests you, because this is a 5-year project. And we're, given that the data collection side of things is in NEON's pocket, we can the funding for the data collection's over there. So we get to think about assuming that the data is going to keep coming, and so our job is to build a challenge and community around it. And so that's what's really excited about this. And so as you're thinking about that, just remember one that give the whole thing the benefit of the doubt if you are confused, because this is, we're doing this for the first time. This is kind of the first time something like has been done across all these themes of ecology at the same time. And so as this evolves, things will get more clear, and we will have a template for how to run an ecological forecasting challenge using network data, which is really cool. And then feedback, don't hesitate to ask questions. Join the Slack channel. That's been really helpful for other themes. You'll get answers to your questions. Email me, email Jody. Yeah. We don't call it a competition. We call it a challenge, specifically because we want it to be collaborative, and we want to tackle the challenge together, not compete against each other. So I will share my screen just to give you a little bit of idea of resources that are out there that you may or may not already be aware of. First of all, there's a video available that, when you're lifting weights or going for a run or whatever, and you want to pump yourself up, watch the video. It's a very short, snappy video. So here is the kind of the overview of the design, but then, one of the things that we have kind of feedback we got was that it was a little bit hard to kind of follow some of the information. And so we created a kind of a book down document that is available at this link, which has a lot of the information here. And the power of the book down document is that we're also can get a version it and have DOIs associated with it to make it citable, and be kind of part of the reproducible open science, as opposed to be embedded in a like a WordPress site. And so here's the theme for aquatics. As a reminder, it's one lake and one river site. It's surface temperature and dissolved oxygen, 7-day forecasts at the beginning of each month. And then here's kind of an overview of it. So something to be aware of is that there's a month and a half delay in NEON data appearing, and that influences when things are due. So, for example, NEON data for the month of May will become available June 15th, in theory. It plus or minus, that kind of thing. And so, that kind of influences the timing of this. So let's see, there's target data, which is the NEON data that has been processed to daily means. And then this is the target file that's provided for you. And so the target file is what you can use to train your model so that it matches exactly how we're going to be processing as the new data comes in. And this gives you the columns here. The temperature and oxygen are not the same sensor, so the depths are not exactly the same. And we just wanted you to know what depth that observation was from, in case that was informative. It's around the 1 meter for both of them. The standard deviations are the error reported by NEON. Let's see. Here's the timeline for you to follow. Let's see, and then the design team. And then you come over here and there's information about how to participate in terms of registering. And you can submit your NetCDF or CSV. And you can, and then your metadata that's EML format that's actually an XML file. I want to emphasize the importance of naming conventions of your files, and that because the automated processing parses the file names to deal with what theme it goes into, what date it goes into, what team it is. So it's really important for you to follow the naming convention, and that's in submission instructions. Let's see, submission instructions. So here, here's the naming convention of the file. You can submit a CSV or a NetCDF, and we provide the exact format you need of those. Importantly, an important component of the forecasting challenge is representation of uncertainty in your forecast. The evaluation criteria that we're using is called the continuous rank probability score, which is how you can evaluate a probabilistic forecast that's provided as a distribution or a set of ensemble members or MCMC draws that can be used to approximate a distribution. And so if you provide too small of an uncertainty or no uncertainty, even if you're really close, you're probably going to score worse than a team that had uncertainty in their forecast and was not as accurate. So it's important to think about how you're representing uncertainty. And within the file formats that you're submitting, uncertainty can be represented in one of two ways. There's two options for the uncertainty column. One is a column called ensemble, and that's where you have replicates that represent kind of random ensemble members or random or draws from your kind of a Monte Carlo propagation. The other is, and that column, what will be labeled is a number, the number for each ensemble member. And then there will be other columns for the values associated with that. The other option is statistic. In that case, you will provide that column will have mean and standard deviation as the only two options in that column. And then the value column associated with that will be the mean and standard deviation. And so you can provide either the statistic or the ensemble member as a way to represent your uncertainty. So down here is the example of a CSV file, and we provide an example of a file that meets the criteria. So you can kind of use that to guide. More than likely, this group will be working with the CSV format because the data, it's not that big of a data, it's 7 days daily, so it's not a huge file. The 30-minute, 35-day forecast, the 30-minute time step, 35-day forecast for the terrestrial carbon and water fluxes, those tend to be more in the NetCDF realm. We provide examples of the metadata format, and the key with the metadata format is that we try to make it as easy as possible by providing some helper functions in R, which I will show in a second. And the metadata format, I need to update. Well, we're working on kind of finishing the documentation and archiving the documentation for the metadata format. And so one purpose of the challenge is actually to test out, because the Ecological Forecasting Initiative is proposing a set of standards that build off of EML, the ecological metadata language, that extend it in a way that allows you to document forecast models. And so that in 10 years or in 5 years, when we're analyzing all the forecasts, we know, hey, this model included these types of uncertainties. This was a machine learning model. This was a process model, et cetera, et cetera. The only way to really know that is with good metadata. And the only way to make it machine readable is with machine readable metadata. And Mike Dietz has led that effort to kind of really hone this in. And so part of the purpose of the challenge is to vet this metadata. So being able to work with that and learning what people are running into and whether it works for them is an important outcome of the challenge as well. Submission process here. And then within a couple, I have to double check. I think it actually runs every 20 minutes now. There's a script that runs automatically that processes your submissions and checks to see whether they're valid. If your submission winds up in the aquatics forecast bucket, then it will then it's a valid script. It's a valid submission. If your submission winds up in what is officially called not in standard, otherwise known as purgatory, then it's also given a log that is probably unhelpful, but is available. And that it failed the checks. So it doesn't meet the standard. And why is the standard important? Is because once it clears the standard, it will be available for viewing on our Shiny app, and we'll be confident that it will be run through the scoring algorithm. And I'll show you that in a second. And then you can visualize the forecasts at the dashboard, which I'll show once we get to the end of this document. There's a little bit of information about how it's evaluated here, and a little bit on the continuous rank probability score, so you can learn more about it. There's some examples. This is kind of cool here. So imagine that your true value is 8 for some reason, and then here's this. So if the true value is 8, the target is 8, and importantly, like the target is the target. Like, so your forecast has to have observation uncertainty in it. We don't put observation uncertainty on the observation because the observation is a real realization of the world. Granted, if you tried to remeasure the same thing again, you may get a different answer. But that measurement is real. And so you need to include observation uncertainty in your forecast because you're trying to forecast the observations. And so here's an example here. Like if you forecasted if the target's 8 and you said it was 7 with a standard deviation of 2, then you would get a score of 0.8. But if you said it was 7 with a standard deviation of 6, you would get a score of 1.6. And so you can kind of see how the response surface depends on both the mean and the standard deviation of your score of your forecast for that particular target. We're producing null forecasts that are basically tomorrow is the same as today. So if that's your forecast model, then let's hope you tie the null. And then see visualization and leaderboard. And then some references. All right, so if you want to use meteorology inputs, you should use the NOAA Global Ensemble Forecasting System. We provide a downscaled NOAA forecast for 31 ensemble members that at every single NEON site. And you can access that through our MinIO system, and I'll get into some helper functions to go after this. So like here's Abbey Road, which is not one of the main sites. You won't be using this one, but I figure out why it's slow right now. But okay, and then here's this, and then these are forecasts. So this is the date of the forecast starts. And then this is a forecast that started at midnight UTC, 6 a.m. UTC, 12 and 1800 UTC, because NOAA generates forecasts 4 times a day. And so we're continually downloading that and making it available for you at all NEON sites. So this is another outcome of the forecasting challenge is we're going to have an archive of weather forecasts for all NEON sites starting last October, September, when NOAA moved over to their Global Ensemble Forecasting System version 12. Let's see. And we are working with NEON to, so NEON has metadata that's available. It's gappy, particularly at the aquatic sites. And we're working with NEON to get gap-filled historical NEON data. And it looks like it'll be pretty close to being available for flux tower sites, and many of the NEON aquatic sites are near flux towers, so that would be usable gap-filled metadata. But we don't have that accessible yet. And then finally, there's a couple packages in R for you to use. One is called the NEON Forecast package, and within that, there are a set of helper functions. For example, you can score your forecast locally. Like to just see what the score is of your forecast without having to submit it to the challenge. You can validate your forecast file by running this function forecast output validator to find out whether it will pass the checks, because this is the exact function that we're using on our CI. And then you can check there's a helpful function for generating metadata. And it's a two-step process, and it's important to follow these instructions. The first step is to run this script, which will basically create a template that is in a format called a YAML, where you can fill out the template. You save that, and then you provide that to this function called write metadata EML, which will write the XML using the YAML, and then tacking on other metadata things that you don't have to deal with, like the geographic locations of each of the NEON sites. We have that already baked for you. The columns and a lot of the attributes, we already have that cooked up for you. And so you don't have to deal with that. That's the cumbersome part. You just need to think about how you're going to describe your team and your model. And that's in the YAML file. Folks have submitted the YAML file. That doesn't work. That will go to purgatory. You have to submit an XML. And so we realize that this is awkward and we're working on a better solution. But this idea of like you produce a very easy to read kind of YAML file, you save that, and then you provide that as an argument to the write metadata function. We provide a function for you to download and create a data frame of the NOAA data for your site. So you don't have to interact with our server. You don't have to work with netcdf files. This will create a data frame for you that has the temperature, all the met variables for a particular NOAA forecast. And so this is a really powerful function for you to work with. You can just get your forecast file here and hit submit and run this R package, and it will submit it for you to the server. So that makes it really easy. I won't get into the extensive details of the NEON store package, but this is a package led by Carl Boediger, and it's on CRAN, and it makes it some aspects of working with NEON data a little bit easier, particularly with being able to check to see if new data is available, and being able to store it locally, and to be able to convert it easily to a database so you can read in high frequency data without crashing your computer's memory, things like that. And that's
Quinn,
available.
Yeah, to add on to that, Quinn, too, during that early career workshop, we'll be also taking some time to go into some more detail on NEON Store and provide code, other code as well, and kind of show how it works out. So
cool. Yeah. Yeah. And Ryan will be leading that session. And then we also, the FE standards package, you won't be working with, but Mike Dietz led the development of this, and it's embedded within the validate your metadata within the NEON forecast package. The NEON forecast package is only available through GitHub, so you'll have to do the install GitHub to pull it into R. And then we have some frequently asked questions. These are the questions that folks have asked, and now we've built this. And so these are available for you to look at and ask more questions, and we're happy to flesh out more stuff here. That kind of thing. Cool. Are there any questions thus far? And then here's our Shiny app. So the Shiny app is our dashboard. So there's the different themes here. There's sort of sub-themes within terrestrial because they wanted to have a daily and a 30-minute one that functionally has turned out to be two different themes with how we've had to deal with the CI. And so, yeah, if you're if your file that you submit does not lead with the word aquatics followed by a dash, it will not get, that's how we know what theme. And so that's why it's really important to have naming conventions. So here, let's see. Let's see what teams submitted to the phenology challenge on the 20th. So in this case, there are, let's see, the Knoll plus 4 other teams. And there's the Green Bears. I assume that the Green Bears are associated with the other Bears, the Cal team. And then here are all the different sites. So you can sort of see how you can see, so you can view for a particular team on a particular date. Let's go back to when it was a little bit more interesting. So 4-2, that one's not interesting because that one was actually a date that not a lot of teams dropped in their submissions on. So here's the Green Bears on that date. And the app is a work in progress. It's accomplishing what we hope to do, but it could be a lot more seamless. So here is the outcome of this particular, at the different, this is phenology, so this is greenness. And so these are genuine forecasts, which is super cool to see. Like we know 100% that these forecasts were submitted before this data was collected. And this gives you an example of the phenology group. And so the aquatics is here. And the aquatics, you'll see a lot of dates. These are all the Knoll forecasts that have been run. There was an early submission because the Virginia Tech group, that I taught a class, and I had them drop their forecast in, and it was helpful because it allowed me to get the scoring and it allowed me to vet the outside contribution part, because the Knoll models are run internally. And so you can see here, there's the two, and then you can choose between oxygen and temperature.
So Quinn, I do have some questions when you're ready for that.
Yeah, I'll do one more thing and then turn it over for questions. And then the other scores here. And so here it's calculating, it's taking the score. So we're going to do phenology and we're going to do all. And if it says it's an app error when you're on this, but it's kind of a little bit of a grayed out red, that means it's just thinking. And so here's the scores here. And, you can come into here. This is summarized across all horizons, all forecast dates. It's not a fair comparison. We can actually, a little bit more fair might be, well.
Hey, Quinn, is the low score good or a high score good?
Low score is better. I can kind of come back here and show you again. Here's a smooth CRPS. Yeah, so like if you have a low standard deviation, you're spot on, you have a low number. So lower is better. And so we can rank here. And so in this case, it's again, this is unfair because not all teams have submitted to all opportunities in case of the phenology challenge. And it's really easy to if you only submitted early in the spring when nothing is changing, you're going to do really well. And so take this for a grain of salt because it hasn't been entirely parsed in the way that we're going to be parsing it. But you can sort by that and see that this, and then you can see relative. Here's the Knoll. You can compare the Knoll. So a lot of teams are beating the Knoll, which is good. And yeah, so the aquatics, you'll see yourself show up here. So anyway, cool. Let's see, I think that's all the overview of all the resources that are available for you. Have I missed anything, Jody, that we've done in these calls?
Yeah, I think you've covered everything that we've gone through.
Mike, is there anything else you would like to add?
Probably just that the standards doc does have a lot of gory details about how to format that metadata and how to set some of those uncertainty flags. And the package that you don't need to be able to submit anything does have some vignettes that show how to specify the file formats and metadata for a few different example sort of forecasts, as well as how to access things that are in that standard, both the data and the metadata.
Cool. All right. Turn it over for questions. I'll leave my screen shared in case it helps to reference something to answer a question.
I'll go ahead and jump in first with a few comments, but then maybe with a couple of, I think, pretty straightforward questions. There are a lot of resources. That was a great overview, Quinn, and appreciate it very much. I know there's been a ton of work that's gone into it, and it's really exciting to see sort of this community effort in not only forecasting but learning about forecasting, and then meeting each other and learning about each other in the process. So I agree, that's super cool. And I think at the end of this first round, there will be a lot of ideas for how the second round could be even more effective than the first round. And so it's also helpful to know that we're part of the larger learning process, and that we'll have an opportunity to feed back to you all some of the things we've learned and wondered about in the learning process.
Yes.
So
yeah, we want year 5 to be well oiled, and that's because of feedback from along the way.
Yeah. My sense is that our team is working madly now to get that first submission ready in a couple of weeks. And I think, the requirements for a submission are pretty straightforward. And so I think we have a handle on that. And, once we get to the point where our workflow will generate that forecast in a way that's submittable and is submitted, then I think we're going to have an opportunity to step back and evaluate how we're doing the forecasting. And so, my questions for you have to do with, so we submit a forecast and we decide, okay, we want to either change the nature of the model or maybe the nature of the framework in which we do the forecasting and uncertainty analysis, from, like a Kalman filtering environment to some Bayesian, approach to solving the problem. And so how adaptable can we be as we move through the summer season in terms of maybe the number of forecasts we submit for any one period of time, how we change our underlying infrastructure, all those kinds of things?
Yeah, so there's 2 options there. One is you can keep with your original idea and keep that going. But then register a new team and just change the team name slightly, because you can see there's a PEG team that has like PEG RF, PEG AB, PEG, and so each one of those is like clearly a different approach. And so I think what I would recommend first would be just register a new team. If it's going to be a wholesale like update to the approach, because then you just keep your other approach, and then we'll learn how that approach, maybe you thought it was a poor approach, but it actually works better. You just wanted to get fancy. The other is just update it in your metadata, because you're allowed to change your model from one, within a team, you are allowed to change your model. You're not locked in. You're allowed to, because the important thing about forecasting is the learning process. And so you're allowed to update your model as you go through. And so if there's small tweaks, things like that, the key is to make sure that they're reflected in the metadata. And so you would change your metadata from submission 1 to submission 2. So those are the 2 options. And I would kind of think, so first of all, that's a good question. That's a question that could go on to the FAQ. And it's up to you on. I would say a large change, register a new team, and it's the registration would be the exact same with a slightly different name. Small modifications, update the metadata.
And then I'll ask one more question and then stop, and hoping anybody from our team is willing to jump in and ask too. There have been a lot of questions about, kind of the fundamentals of forecasting, especially questions about dealing with missing data and, propagating uncertainty through the forecasting framework, that kind of thing. And knowing that there are a lot of different resources out there, we're wondering, is there something that you think is particularly well tailored toward either aquatics, some kind of presentation or a publication that would be most useful?
Well, first is a plug for the summer workshops from the that the FERCN is running. Which are about, first is an inclusive pedagogy workshop to think about, how to approach teaching forecasting in the most inclusive. And the second one is focused on kind of vetting, surveying, discussing, and then making a plan and doing the active organizing a lot of what is out there into things like what you just said, Paul. Like, hey, like people are like, we need a good tutorial in this. There's all these different things out there and we like some bits and pieces of all of them. Let's think about one, or let's just categorize all these things in a way and organize them in a way so that they're easy to find. And so there's an educational workshop that builds on what was learned in the inclusive pedagogy one. And so you don't have to go to both to be involved. So that's a plug for that. In terms of the null model is one resource. That's available on GitHub. I don't know if you've seen that. That's one resource. That is a Bayesian kind of, propagation that uses, basically Monte Carlo Markov chain to kind of propagate uncertainty.
Yeah, that's where we started.
Yeah.
And then jumped over to Jake's example.
We do have, resources available. It's hard that Mike put in the resources. But if there's something in particular that you are looking for, it'd be very helpful to know what that is. Yeah, and Mike wrote in there stuff that's within the resources. But there's no like, this is how you have to do it. There's no one answer.
I think we're kind of excited to see how different approaches work. I mean, we could easily see some folks taking very mechanistic process-based approaches, some using very statistical approaches, some using machine learning approaches. No idea which is going to do best. Some might just refit their model to the data every time. Some might use, sophisticated data assimilation algorithms. Some are just, using simple historical means and being like, well, probably do decent. It might not do the best, but it'll probably do decent. Yeah, there's going to be a whole range of complexities and approaches. But yeah, I mean, there's also like I said, Quinn said, a whole lot of folks within FE that have been working and kind of trying to compile educational resources and stuff like that. And while it doesn't help for this round, the week-long short course that we do will be offered in January, which will help with the next round quite a bit. It's usually a summer course, but because of COVID, BU wouldn't let us do it on campus this summer. And so that'll be like the fourth iteration of that course.
Cool. Other questions?
Is there a plan if the sensors go down?
No. I mean, that, I mean, there's 2 sites, so that's hopeful, and, fingers crossed, but that's just the nature of the beast.
Yeah. So if I switch to my Neon Science Advisory Committee hat, yes, some of the aquatic sites definitely go down from time to time. They tend, the ones most susceptible tend to be the northern sites in these shoulder seasons, which these aren't, and then any other kind of high flow events. Neon usually gets those back online as quick as they can. So there may be gaps, there may be large gaps, but the odds of losing both sites completely for the duration is probably pretty low. And these aren't the only 2 Neon sites. I mean, I think one of the aspirations in later rounds is to kind of build off what we do in the first round to bring in more sites and a greater diversity of ecosystems as the challenge progresses.
I mean, of vulnerable sites that are vulnerable to this issue, realize that this is the challenge that's most vulnerable, because it has the fewest number of sites and it only is occurring once a month. And it only has 7 days. So, those are all decisions that the design team made that could be refined in future years. But that is just something to be aware of. So, our own sensors at our own sites go down all the time, and that's just the nature of the beast.
I might argue that the tick challenge is even more sensitive to the extent that they decided to work with 1 year lag data instead of 1 month lag data. Because, that data is had some issues in 2020 with COVID and real latency whenever you deal with the organismal data, which is the beetles and the ticks, because it's not collected by sensors. So the sensors data, I think Neon does a much better job of keeping that online.
Other questions?
I think just to congratulate you, because this information is amazing, and this challenge is, everything is very set up, and like knowing nothing about forecasting, I always want to people explain me what I am doing, but I think it's a learning process, and we have to try, as you said, there is no optimum or perfect model, we have to try and keep improving. And also thanks for all these resources, just to keep checking. And for example, yesterday that we did the Gleon GSA Limnos series was very cool, to go over it. But then I was I really want to discuss more about how we calculate uncertainty or all this ensembling thing. What does it mean? So I was hoping to get more conceptual information about what is a forecast or what are we doing through the scripts. But I think just going through the challenge process, we are kind of learning this between us, I would say. I don't know, probably Mohammed and Robert will say that they are doing all the work, and I am just here trying to figure out what I'm doing. But so if you think that we have all the tools right now to keep learning, I guess that's what we have to do, just to keep trying to, as Paul said, to submit this first model and maybe try to improve it and keep learning.
I mean, you're submitting a model, you're submitting a numerical representation of the future with uncertainty before the data is collected. That's a forecast. So, whatever you're doing is, you shouldn't feel like that's sort of do I have to do a forecast right? I mean, the act of doing that is discovering what forecasting is. So that's important. It's not some I don't know, secret passcode you have to enter in your Nintendo video game to unlock the secrets of forecasting. the act of contributing this challenge is developing a forecast. So that's exciting. But this is a means to an end of growing a community, and developing the resources and learning more about how to become better at forecasting nature. And so, your involvement and your feedback and your engagement over the RCN is what's going to make everything successful. Cool. Yeah, Mike.
The secret to forecasting is getting comfortable with being wrong a lot.
Yes.
Because, whenever you're predicting the future, this is the nature of this activity. You need to make a specific, quantitative, falsifiable prediction about something that hasn't happened yet, which guarantees you will be wrong a lot. And in some sense, I think that by just fitting models post hoc to data that's happened in the past, I think get it sometimes an overly optimistic sense of how we're doing, when in fact we're just overfitting. Forecasting is protection against overfitting, and it's a way of learning faster. We get to check every month if we learned anything or not. And I draw a lot of inspiration from things like numerical weather forecasting, where if you look back when they were at this stage, they were likewise doing worse than chance at forecasting. And right now, if you look at the correlation coefficients between their predictions and observations, like 3 or 4 days out, they're like, 0.95, 0.97, like they're nailing it. But it took decades of failing every day before they nailed it. But we only get better at this by doing it. And that's probably, to me, the biggest thing I believe in all of this is we only get better by doing it. And if we sit back and wait until we're good enough, we will just never get there. So, yeah.
Yes. Mohammed?
Yeah, first of all, thank you very much. That was very inspiring. I have a couple of mechanical questions, so to say. First of all, for this lake and also the Greek, we have some NAs in the driving data, so in the observation data from NEON.
Yes.
Which might cause either our model to crash, so we have to cheat around this. Will this be universally dealt with, or we have to deal with this on our own?
You have to deal with it on your own. Real world data has NAs.
Right, fine. I mean, there are a couple of ways, but okay, fine. That's fair.
Yeah, I mean, otherwise we would be imposing a model to gap fill it. And so you wouldn't be forecasting data, you'd be forecasting our model.
True. The problem was mainly with this. I don't think this will be happening with the ensemble we'll be getting. It was more with the observations of the air temperature.
Yes. Neat. So we could work towards that, but we don't have gap-filled driver data. That's something that we could provide. We wouldn't fill the gaps on the target data. NEON is working towards that. There's also other resources like NLDAS, or you could actually stack the weather forecasts, the first day of the weather forecasts, to build a continuous data, net product. So there's some groups are coming up with creative ways of dealing with this, but you're hitting a nail on the head of that. That's actually the common request from everybody, is gap filled met data up to the point that the forecast needs to be generated.
Which NEON and NCAR are collaboratively working on, and they just haven't gotten that product out yet. But it'll, like Quinn says, whatever's gap filled will ultimately be a model. But there are a bunch of different great products. If you want daily data, there's things like DayMet and stuff like that. And if you want sub-daily data, there's a bunch of reanalysis products like NLDAS and ERA. I personally love ERA 5.
Me too.
Because it's hourly and it comes in on ensemble form, so you actually have that ensemble uncertainty.
Yeah, me too. But the problem with ERA 5 that it fails in some locations with some variables. So with air temperature, usually you get like really good correlation with on-site observations, but when you get into something like precipitation, you get way off.
Yeah, that's just, precipitation is so heterogeneous, and atmospheric models in general tend to produce a constant drizzle more than a discrete pulse of rain event. It's kind of, yeah, it's tough.
But if you create a tool to like possibly process something for a neon site, we encourage you to kind of make that tool available to the community, and we would be happy to host the tool or be involved in that. That's kind of where the Neon Forecast package came from, was just a set of tools that were needed to solve these challenges that people are repeatedly solving.
Yeah, well, due to time constraints, I was only thinking about just copying the missing dates from Euro 5 for air temperature, just like have things running. I can provide codes for that. That's not a big deal. It's just a couple of lines of code. The other thing was we will be using, just to clarify things, we'll be using the CRPS script provided in the null model to verify our forecast, correct?
Well, we do it automatically for you.
Well, I'd like to do this for my handcast just to test how good I was doing.
Yes, that's that's available for you to use. It's in the Neon Forecast. It calculates a CRPS for your forecast. What I said, I meant that you don't have to calculate it to submit it, like you don't have to worry about calculating it. We do that for you. But if you want to calculate it yourself locally, then there's a function available for you to do that.
Oh, then I misunderstood something. I thought when we submit, we have to provide uncertainty calculated as CRPS.
Oh, no. Uncertainty is just either through a set of ensemble members or by giving the mean and standard deviation.
Okay, right.
That is then input into the CRPS calculation to determine your score.
Grant.
To be crystal clear on the CRPS, that's in the forecast package?
Neon Forecast has a function called score that will run that for you. Okay. You can look in that GitHub code to actually see, because I think it's within the this package called scoring rules, has the actual CRPS calculation, but the scoring function does all the wrapper and organizing of the data by date and time and all that kind of stuff you need to do to actually calculate the score. Does that help? Does that clarify?
That clarifies a lot. So last question is, I was trying to run the null model on my own and I ran into some errors. So who to scream for help?
That would be me.
Okay, right. Okay, I will be showering you then with some questions.
Okay.
Yeah. Thanks a lot.
Yeah. Thank you. I mean, this is only a function of the folks who want to contribute. So don't hesitate to reach out, join the Slack channel, give feedback, have fun.
Will do. Thanks.
All right. Cool. Well, it's the end of the hour. If there's no other questions, we'll adjourn and look forward to seeing your forecasts.
Thanks. Bye.
Thank you. Bye.
Thank you.